Welcome you to this presentation. Here we're going to answer with you 2025 GCE Physics C1. Okay, so here the question reads: a car slows down from a velocity of 40 meters per second to 20 meters per second in 5 seconds. It then moves with this velocity for 3 seconds and then comes to rest in 2 seconds. The first question, here, what I've been given is plot a graph of velocity against time for the motion of the car on the grid. So here now, as we all aware that there is nothing like a separate answer sheet. Okay, so both the question paper and the answer sheets are being attached to this same question. So here we are asked to answer this on on the grid provided. So here I don't have a grid, I'm going to use a graph paper. Okay, so here we are going to use a graph paper to show this, to plot a graph of velocity against the time for the motion of the car. Okay, so now as you can see, this question was very easy, in such a way that you are able you have been given the velocity. Okay, this is the final velocity, and this is what the second velocity, where this vehicle will move. So it will move this one here. Now it becomes the initial velocity, and this one will be our final velocity in 5 seconds. So here now our only scale will be used, okay, in each axis. So as you can see here, okay, as for me, I'll start, let me use this space here. So this space here, I'll say this is 40. Hope you are able to see this is 40, which is meters per second. So here it's velocity. So here velocity, I'll simply say velocity. So here I'll say it's velocity. Then there I have, this is 40. Here velocity meters per second. Then having this velocity, I can say here again I have okay, so here I'll put 10, then here I'll put 10, then oh sorry, not 10, I'll put 30. Okay, then I'll also put 20 this side. I'll also put 10, then I'll also put what, a 0. So which means here I'm saying that 2 centimeter to represent 10 units up to 40 this side. Okay, then from the here again I'll use this one 2 centimeter to represent 2 units. So here I'm going to have a 4 this side, then this side a 2, then 4 here, 6 here, then 6. I'll also put 8 this side. Okay, so here 8. This is how I'm going to move 8. Then also I'll put here 10. Then I also put a 12 here. Okay, and here it is time. Okay, so here it's time, and this time should be in second. Okay, so now the reason why I've put like this, I've just added what I've been given. Here we have been given 5 plus 3 we get 8, 8 plus 2 you get what, 10. So this is the time that I have. So here we are I'm saying that 2 units, 2 centimeter to represent what, 2 units, 2 centimeter to represent 2 units. So having this, which means I can now draw. Okay, I can draw this. Okay, so now as you can see, a car slows down from a velocity of 40 to 20. So this one is going to drop from here. There is 40 to 20. So 20 is this. Is this now. What will guide us is what? The time. In how many seconds? In 5 seconds. So here we've got 2, 4, 5 is this here, the middle part here. 1, 2, 3, 4, 5. So this 5. Then for us, 5 is going to be equal to 20. Okay, so it's here. This is how the point will be. So it will move from here up to this. So that is what the time that is going to move. So it will move like this. So I'll join these 2 points from 40 to 20 in 5 seconds. So it's going to move like this. So this is how it's going to move. So this is a retardation, okay, because we are told that it slows down. So it is retardating from this point up to this point, okay, in 5 seconds. So from here up to this point here, it's what? 5 seconds. Then it then moves with this velocity for 3 seconds. So here, this 3 seconds we add to 5. 3 plus 5, what are we going to get? It's what? 8. So up to this point. So here, it's going to move up to this point, okay, with the same what? Velocity. So here, I'll join these 2 points. Okay, upload this. Okay, so this is how it's going to be. Then again, apart from that, and then comes to rest in 2 seconds. So 2 seconds, we are going to add 2 plus 8, this 8 here. So 2 plus 8, you get what? A 10. So here it will just move from this point up to this point. So this is how it's going to move, okay. So it will just move like this. You are done. So this is how you are supposed to plot this, or to answer the first question, which is this one. So you just answer like this, you get the full mark, which is 4 marks. Just answering like this. Make sure that you name your graph. This is velocity, and this is what? Time. You also put here on top, which is velocity time graph, okay. So here you put velocity time graph. Okay, so this is how you need to draw like this, okay. Need to draw like this. You show velocity time graph, then this is how it moves from 40 to 20 in 5 seconds. Then it maintains with this for 3 seconds. So you add to 5, which will give us 8 here. Then from 8 it comes to less in 2 seconds. So the time that is passing here is 2 seconds. So you just drop like this. This is how you can draw this question. Then question B, calculate the retardation in the first 5 seconds. So we're going to use this graph, okay. We use this same graph to calculate the retardation. So here the retardation in the first 5 seconds. So you can see here there's this, which is 5 retardation in the first 5 seconds, which is this here 5. So it's here from here up to there. Since we have just been given this direct, so here we'll say which is B1, okay, B1. So B1, we know when calculating this, it's acceleration retardation, which is A is equal to, we say final velocity, okay, V minus initial, okay. So we just use U, or you can use V or U like this. then over time taken. So in this case, our final velocity is this, because it is coming from 40 up to 20. Okay, so this is our initial and this is our final. So here our final is what? 20 is the one that we are going to replace where there is what? A v. Then where there is u, replaced by what? 40, because u here represents what? The initial velocity. So a is equal to 20 minus 40 over time, which is what? 5. Okay, then this and this will give us a is equal to negative 20 over 5. This into that will give us a is equal to negative 4 meters per second squared. So this is what? The retardation. You are done, you get the 2 marks. Then total distance covered by the car. Okay, so here now they want the total distance covered by the car. And when calculating here the total distance, okay, I'll use this space here. The total distance covered by this car here, we'll say the formula that we are going to use, we are going to use the area under the curve. Okay, so area under the curve, we'll say it's a distance. So distance is equal to, so I'll say half. Okay, you can, if you want, you can just use a pencil and you name this part and the other part. So here I'll say it's half. Okay, half like this, bh. Okay, and then plus I'll also use the other part, which is half again, then bh. Okay, so here now what I'm saying is, if at all you've used a pen like this, you can also use a pencil. And this now pencil, what you're going to do, you can draw a faint lines. Okay, you can draw a faint line like this. So this one, it is now what I have here, it is what? The trapezium. I have, this is a trapezium and this is what? It's a triangle. So this top part here is a triangle and this one up to this side is what? It's a trapezium. Okay, so now the formula that I'm going to use is this one. Okay, here what I'm going to do is, from here up to this is my height, and here my height is 20. Then from 0, the distance here, we can say from here up to this is 10. Then we also have the top one, which is from here up to there. So here it's 8. Okay, so from here up to this side it's 8. So here I'll say this is 8. Okay, and this is 10. Then the height here is what? Is 20. Then what I'll do, I'll just replace this distance. Then here it's half. Then here it's my b. So here b now, I'll take this part, which is from 0 to 10. It is what? 10. This distance here, it's 10. Now this 10, I'll say 10 plus, from here up to this is what? 8. So 10 plus 8, I'm going to have what? 18. So where there is b, I'll put 18. Okay, where there is b, I'll put what? 18. Then times h here is from this side up to this, it's what? It's a 20. So there I'll put what? 20. Then plus half again. This is a triangle. Okay, this is a right angle triangle. So here again it's half. Then from here up to this side it's 5. Okay, so from here up to this side is 5. So here I'll just simply say base is 5. Then times my height here from here up to there. Then once considering this, which means we are going to remove this part here. Okay, so now from 20 we remove here we remove 20, so this is if this is 0, this is 10, this is what 20, so even that height is what 20. Okay, so this is it. Once you remove this part, just remain with something like this. So 0, 10, 20. Okay, so this is what we have. Then having this, here we can find the half of 20. So this one here it's what? It's 10. Okay, so here it's 10. On this side is 10. Then 10 times 5 will get what? A 50. So here I'll say plus 50 this side. Then here again it's 1. There it's what? 10. 10 times 180. 10 times 18 you get what? 180. So this is what we have. I've got 180 plus what? 50. 180 plus 50, what's the answer here? We'll get a 230. Okay, so get a 230. This is what the answer. Distance is measured in meters. Okay, so this is how you are supposed to answer, which is 230 meters. Okay, so now this formula here, if I tell you you are confused on this one, you can still use this, which is distance is equal to half. Okay, like this. Then you open bracket a plus b, then 8. It's one and the same thing, just as here. Here you also put as you can see from here up to there it's 8. So if at all you consider this one to be your a, there you put 8. Then from here up to there it's 10, you put 10. Then you add them, you simply get what? 18. So this is just a shorter way of solving this one. Okay, so having this as our distance, then we're going to use the same distance to find the average speed. Okay, so there I'll get 2 marks. Again, the last question is section C1, the average speed of the car. So the average speed of the car is the total distance over time taken. Okay, so which is B3. Okay, B3 here, we'll say it's B3, which is the speed. Okay, so I'll say speed is equal to total distance over time taken, which is t. So here the total distance here, it's this one, it is 230. So here we're going to have 230 over the total time from 0 up to this is what? 10. Then over 10. So 10 into this here, remember this is in meters and this is what? Seconds. So here and this one will reduce. What you're going to have is 23 meters per second. So this is how you need to calculate this what question. Okay, so if at all there is any question, feel free to ask and comment on the comment section. Thank you very much.